In this video, we're going to be finding the center and radius of a circle using an equation that is not in standard form. For example, we have the equation x squared plus y squared minus 2x plus 6y equals 6. So we can see that it's not in standard form because we don't have the quantity squared, like x minus 4 squared. We have this negative 2x and 6y, so we've got some first degree things going on here. This is not in standard form. How do we get it into standard form to be able to identify the center of the circle? We're going to have to complete the square twice. So how do we do that? First thing is any constant needs to be on the right hand side. So that's done. All the variable terms need to be on the left hand side. Then we're going to group our x's and our y's. So I'm going to rewrite this as x squared minus 2x, and then remember we're going to find that perfect value to complete the square with. Then the y's of y squared plus 6y plus some perfect value to complete the square with the y's. And that equals 6 plus whatever two values that I found on the left-hand side. So remember, to find that perfect value, we use b over 2 squared. And we're going to do it separately for the x's and for the y's. So looking at the x, we look for that b term, which is always with the x to the first degree. b is negative 2. So we take negative 2 divided by 2 and square it. Negative 2 divided by 2 is negative 1, and negative 1 squared is positive 1. So I'm going to add 1 to both sides of my equation to keep it equal. Same thing with the y's. The b term is 6, because that's with the y to the first degree. So I'll take 6 divided by 2, square it. 6 divided by 2 is 3. 3 squared is 9. I'll add 9 to both sides of my equation. And then we factor, right? So we factor this trinomial with the x's, and we factor the trinomial with the y's separately. If I did it right, it should factor into a perfect square binomial. So x, remember the trick was this value before we square it, x minus 1, that quantity squared. We can check it. Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. Same thing with the y. So y, this value before we square it was positive 3 squared. 3 times 3 is 9. 3 plus 3 is 6. So that checks out as well. We add together the values on the right-hand side. 6 plus 1 plus 9 is 16. Now that's in standard form, we can pull out the center and the radius. The center will have opposite signs of our equation. So this was minus 1. The x value will be positive 1. And the y was positive 3. So that y value of our center will be negative 3. So our center is at 1, negative 3. And the radius will be the square root of 16, which is 4. And there you go. Why don't you try the next example? And my tip for you is we don't want coefficients with the x squared and y squared. So you're going to need to think about how to get rid of that. Let's see how you did. So we have this equation, 3x squared plus 3y squared minus 12x minus 30y plus 12 equals 0. We want to find the center and the radius. So we can identify that this is a circle because we have both x squared and y squared in our equation. And so the goal is to get it into standard form to be able to pull out that information. So first I'm going to get rid of this constant by subtracting 12 from both sides, because I want only the variable terms on the left-hand side. But then I also notice that we have these coefficients with the x and y squared. I don't want to have any coefficients there, so I need to divide everything by 3, both the left-hand side and the right-hand side of my equation. Now I have x squared plus, I'm going to group my x's, so the 3x squared divided by 3 gave me the x squared, and I'm going to group it with this negative 12x. So negative 12 divided by 3 is negative 4. So negative 4x, and then we're going to have some perfect value later on. And then I do my y's. So 3y squared divided by 3 is just y squared. And negative 30y divided by 3 is negative 10y. Plus some perfect value. And that will equal, on the right-hand side, negative 12 divided by 3 is negative 4, plus those same values that we found on the left-hand side, or we will find. So for the x's, we do b over 2 squared. b is negative 4. So negative 4 divided by 2 is a positive, or sorry, negative 2. Negative 2 squared is positive 4. We add 4 to both sides of our equation. For the y's, we take our b term, which is negative 10, divide it by 2 and square it. Negative 10 divided by 2 is negative 5. Negative 5 squared is a positive 25. We add that to both sides of our equation. Then we factor, grouping the x's. X squared minus 4x plus 4 should factor into x minus 2 squared, right? This term here before we square it was negative 2. And we can check it. Negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4. Then we factor our y terms. So it should factor into y minus 5 squared. So again, this term here before it was squared was negative 5. And negative 5 times negative 5 is positive 25. Negative 5 plus negative 5 is negative 10. So that checks out. On the right-hand side, we have minus 4 and plus 4. Those are 0, and we're left with just a positive 25. Now we want to identify the center and the radius of our circle. The center will have opposite signs of our equation, so the center will be at positive 2 and positive 5 for the coordinate, and the radius will be the square root of 25, which is 5. And there you have it. So an equation of a circle is not in standard form. You have to complete the square twice to identify the center, and then whatever on the right hand side you take the square root, and that is the radius.